This is question number 27 on the June 2014 calculator paper. Okay, so let's look at this question. The question says ABCD is a parallelogram. All right, so they've told us that the shape is a parallelogram, and we could see it from here. It has opposite sides parallel. It tells us that AC is 9 centimeters. There it is. DC is 11 centimeters. Angle DAC, which is this angle here, is 100 degrees. Calculate the area of the parallelogram. Give your answer to 3 significant figures. Okay, so given that this is the last question on the paper, right, it is quite a challenging question. You do need to use a fair bit of maths, and if you're aiming for top grade, this is one that you definitely should be able to do. Now, thinking about this, right, this parallelogram, they've drawn this line across. This is a bit of a hint because it splits the parallelogram into 2 triangles, and these 2 triangles are equal in area. That diagonal cuts the parallelogram into 2 triangles of the same area. So I'm thinking that if I could work out the area of one of the triangles and then double it, I'll find the area of the whole parallelogram. To work out the area of a triangle, we have 2 formulas that we should know at this stage. A half base times height. I know the base. I don't know what the height is, but the other formula I know is on the formula sheet, and the formula is a half AB sine theta. So area is a half AB sine theta. Okay, now that's the angle between the 2 sides A and B. So I know 2 sides of this triangle, and if I knew this angle over here, I could use this formula to work out the area of this triangle, which I could then double to find the area of the whole parallelogram. But I don't know this angle. Could I find this angle? Now, at this stage, I'm looking, I can see I know one angle, I know 2 sides. I could use the sine rule. At this stage, if you went to your formula sheet, on your formula sheet, we've got the sine rule. Side A over sine of A, the angle opposite A, is equal to B over sine B, the angle opposite side B, and so on. And this is the formula that I'm using to work out the area of the triangle. So I'm going to use the sine rule to help me work out one of the missing angles, and then use that to help me work out the area of the triangle, which I'll then double to work out the area of the parallelogram. Let's do that maths then. So I'm going to use the sine rule to work out the area of, a missing angle. Now, the sine rule is A over sine of angle A and B over sine of angle B. If I think about what I know this pairing here. I know 11, and the angle opposite it is 100. So I have 11 over sine of 100 is equal to, and the only other side in this triangle I know is this side 9, and the angle opposite it is angle D. I'm going to just label it there. So I know 9 and I know angle D, and so that's going to be sine D. I'm going to use the sine rule to help me work out angle D. I'm thinking that I know 2 angles in the triangle. I can work out the third. Then I could use this with my formula for the area of a triangle to work out the area of that whole triangle, which I'll then double to find the area of the parallelogram. So I'm going to just focus on this bit of maths now. Looking at this, if I cross multiply, I'll get 11 times sine D is equal to 9 times sine of 100. If I divide by 11, I'll get sine of D is equal to 9 times sine of 100 over 11. I'm going to use my calculator to work out what this is, and let's do that. I'm going to use the fractions key and do 9 times sine of 100. Don't forget to close the brackets, and go underneath and divide it by 11, and that gives me 0.805 0.80575. So that's 0.80575. To work out D, I need to do the inverse sine of 0.80575. Okay, so I'm going to go about doing that again on my calculator. Shift sine 0.80575, and that gives me 53.68. I'm just going to keep it to 2 decimal places, 53.68. Okay, that's the angle D. But I need to know, back up here in my triangle, I know that this angle here, I've just worked out, is 53.68. To work out this angle, my maths is going to be 180, take away 100, take away 53.68. And I'm going to get my calculator and do that. 180, take away 100, take away 53.68, and that leaves me 26.32. 26.32. So to work out the area of this triangle ACD, I'm going to do 1/2 times 9 times 11 times sine of 26.32 degrees. Let's do that. Area of triangle ADC is 1/2 times 9 times 11 times sine of the angle between them, which we just worked out was 26.32. Back to my calculator, I'll enter all of that. 1/2 is 0.5 times 9 times 11 times sine of 26.32. Don't forget to close the bracket. And that gives me 21.9475. It's 21.9475, and so on. Now the area of the parallelogram is going to be 2 times 21.9475. I've still got that result on my calculator. I'm going to times it by 2, and that's given me 43.895. That's 43.895, and so on. Back to the question itself. The last part of the question says calculate the area of the parallelogram and give your answer to 3 significant figures. 3 significant figures. Make sure you're counting from the front. 1, 2, 3, and we're going to chop it off there. That tells me that my answer is going to be 43.9 centimeters squared. I'll put that in my answer space, and there we have it. Now this is a question which, if you're aiming for the top grade, you should definitely be able to do. Right? It's something that you should practice, and given that a lot of the formulae that you need are given in the formula page, right, make sure you do give yourself a decent go at getting the marks for this. Okay, I've just shown you the whole question, right? You could look at it, make sure you could follow it, do all stages of it, and make sure you understand it completely.